So on the back side here of 8.2, we're doing our other, hey guys, special right triangle. So you should see 30, 60, 90 theorem at the top on the back side of 8.2. So flip your papers over until you find the page. Alright. Okay. At the top or over to the side in the margin, I would draw yourself a 30, 60, 90 right triangle. Okay. Either at the top or over on the side of the back side of 8.2. Draw a 30, 60, 90 right triangle. Remember the 30, the 60, and the 90, those just represent the angle measures. Okay, like any right triangle, across from the right angle is called the what? Hypotenuse. So label that as your hypotenuse. The other two sides are called legs, but we're going to get a little bit more specific in this type of triangle. Across from the 30-degree angle, which is the smaller angle, is called our short leg. Then across from the 60-degree angle, which is a bigger angle, we call that our long leg. So we've got a short leg and a long leg, still legs. Don't always go by what they look like in length, because you know I don't always draw my pictures to scale. Always double check if it's across from the 30 or the 60 when you go to do this. The theorem, two parts. The length of the hypotenuse is twice the length of the short leg. So if my short leg was a length of 7, how long would my hypotenuse be? 14. And that's typed out for you already there below that. When I write it out though, maybe you want to write it this way too. I always say the hypotenuse equals short leg times 2. I think yours has 2 times the short leg, but either way it works. So the first part of your theorem, the hypotenuse is twice the length of the short leg. The second one says the length of the longer leg is the square root of 3 times the shorter leg. So if my shorter leg is 7, then I'm going to take this times the square root of 3. Can I multiply the 7 and 3 and make 21? So are they both under a square root symbol? No. So then in this picture, my long leg would just be 7 square root 3. You take your short leg times the square root of 3. Again, when I type it or write it out, long leg equals short leg times the square root of 3. Again, those are all typed for you. They're just in a different order. So when I put these on the whiteboard and stuff, that's how I'll write them out. Works kind of the same way as Wednesday. It's a lot of substituting and then just using your algebra skills from there. If you have square root symbols, you're going to have to break down or rationalize today. Okay. First example. Find the value of each variable. Use your 30, 60, 90 rules to find the lengths of the legs. For today to start, I would start by labeling your triangle. Hypotenuse, short leg, long leg. So you know for sure what's what. Across from the 90 is our hypotenuse. So we'll call 4 square root 3 hypotenuse. Opposite of your smaller angle, the 30-degree angle, is your short leg. And opposite of the 60-degree angle, y, would be your long leg. On the top, we have 2 rules. One of them says hypotenuse equals what? Short leg times 2, good. And the other one says the long leg equals, good, short leg times radical 3. So from here, you have to look at what's given to you to decide what rule to use. You're not always going to use the same rule to start every time because it depends on what they give you. What do you think? Should we use the hypotenuse rule or the long leg rule? Yeah, because they give me the hypotenuse. So I'm going to take what I know and substitute it in. Instead of hypotenuse, it's going to be 4 square root 3. Equals, instead of short leg, what should we substitute in? X times in blue is what I substituted in. I need to get this x by itself, so I have to move my 2 to the other side. If they're being multiplied, how do I move 2 over? Divide it. So we're going to divide both sides by 2. Cancel on the right side. So then we have x equals 4 square root 3 over 2. Can you simplify that fraction any further? Yes, because the 4 and the 2 are both outside. So 4 divided by 2 would be 2, right? So there's your x value. Okay, then we still have to find the long leg, y. We're obviously probably going to have to use the long leg rule. So instead of LL, long leg, we're going to substitute y in. Equals the short leg. What's the length of my short leg? 2 square root 3. It was x, but we figured out that now it's 2 square root 3, so we're going to put 2 square root 3 in there. Times the square root of 3. So again, what's in blue is what I substituted in. Can I multiply any of these numbers here on the right side? The square root of 3 and the square root of 3, because they're both square roots. Square root of 3 times the square root of 3 is the square root of, and the square root of 9 is, and 2 times 3 would make, so then y equals 6. Okay, they're supposed to be shortcuts. You don't have to use a Pythagorean theorem. You actually can't until you know 2 sides. You know at least 2 sides to use a Pythagorean theorem. Alright, try number 2. The longer leg of a 30/60 has a length of 18. Find the lengths of the shorter leg and the hypotenuse. If you need to, draw a picture. Make sure you put 30 degrees and 60 degrees in it so that you have your long leg and your short leg in the right spot. And then fill in your rules from there. Or read carefully and just substitute. It's really up to you. You don't have to draw a picture. Keep them in exact form unless it's otherwise noted. Remember, exact means whole number or square roots. Okay, here's a picture that I drew up here. My longer leg had V18. I called my short leg X and my hypotenuse Y. It doesn't really matter what variables you give them. Make sure you don't confuse yourself. They give me the long leg, so then I should probably use the long leg rule. Sarah, what's the long leg rule? Say long leg equals what? Good. So if I go to substitute my values in, Sarah, what should I substitute in for long leg? Good. According to my picture, what would I substitute in for short leg? Cool. And we have times the square root of 3. So there's your first starting equation. How do I move my square root 3 to the left side? Divide. They cancel on the right, that's why we did it. So we get x equals 18 over square root 3. Would that be exact form? Can I leave it that way? No, I have to rationalize. So multiply the numerator and denominator times that square root of 3. In the numerator, 18 is on the outside, square root of 3 is on the inside, so this is just 18 square root 3. Down in the bottom, they don't cancel out, you gotta multiply them. Square root 3 times square root 3 is the square root of 9, and the square root of 9 is 3. Can I reduce this fraction? Yeah, 18 over 3 would become, so then your x value for your short leg, she gets 6 square root of 3. Larry?
Would you carry the square root of 9 over, and then like it would be square root over 3 over square root of 9, and then do like 1/3, like have a 1 be on the inside, so that way it just be, oh, that's,
You need to go right back to where you started.
never mind.
Good thought though. Good. Okay, so there's your x value. We now know this is 6 square root of 3. But we still have to find the length of the hypotenuse. Grace, your hypotenuse rule from the top of the notes, what's that say?
Hypotenuse equals short leg times 2.
Good. So what should I substitute in for the hypotenuse there?
Y.
Y, good. Equals, what should I substitute for short leg?
6 square root 3.
Good, 6 square root of 3. And then we have to take that times 2. Which two numbers, Grace, can I multiply together? Good, the 6 and the 2 because they're both on the outside. So then you should have gotten 12 square root 3 for your hypotenuse. Questions on those first two examples? Okay, almost about half, if not over half of your worksheet today is like that. They're just triangles and you're finding the missing sides based off what's given. Okay, you won't always start with the same rule. Just depends on what's there. I'll have a couple word problems, and then you'll have a couple of these area ones. We're going to do 2 of these area ones. So on number 3, a rhombus-shaped garden has a perimeter of 100 feet and creates acute angles of 60 degrees. They want us to find the area of the garden to the nearest foot. You might want to write this down maybe on the side and kind of circle it or star it. The area of a rhombus is found by taking base times height. That's one way to find the area of a rhombus. There's more than one. For any type of polygon, whether it's a triangle, a square, rectangle, rhombus, whatever, your base and height have to be perpendicular to each other. So the base and the height are going to create what then, you guys? A 90-degree angle. Okay? Doesn't matter what kind of polygon you have, base and heights always create 90-degree angles and they're always perpendicular. For a rhombus, our base is going to be any of the sides. Okay, so any of the 4 sides could be the base. The height has to be perpendicular to that, so we're going to draw in the height. So starting from your top right corner, draw in a perpendicular segment down to the bottom. This is the height of the rhombus. And it makes a right angle with the bottom of it, which would be the base then. That whole bottom segment is the base. So if I knew what the bottom was, and if we knew what h was, we would just multiply them together. That's going to give us the area, the amount of space on the inside. Reread it here. A rhombus-shaped garden has a perimeter of 100 feet and creates acute angles of 60 degrees. Well, the 60 degree is already labeled in there, but we haven't used anything yet about the perimeter. What's perimeter measure? What? The outside, the distance around the figure. So I know that all 4 sides added together have to be 100 feet. Can I find this length of just one side then? Yeah, how? The sides are congruent. Go back to chapter 6, way back in geometry, or excuse me, January. A rhombus has 4 congruent sides. So what plus itself 4 times is going to be 100? 25. Good. You're going to take 100 divided by 4, and that tells me that each side length here is 25 feet. When we drop that perpendicular line down, that altitude, that height, all the different words you can call it, we create a right triangle. Okay. Here's my 90-degree angle. My 60-degree angle is supposed to be this one right here in the corner. So this little sliver up here would have to be what in degrees? 30. So not only is it a right triangle, it's a special right triangle because it's a 30, 60, 90. The 25, what part of our 30, 60 is that representing? The hypotenuse. I'll only The height has got to be one of my legs. Is it the short leg or the long leg? Long leg, because it's across from that 60-degree angle that was already there. Which means this little chunk down here, that's my short leg. In order to find the area of this rhombus, I have to know its height. So now just looking at that little 30, 60, 90 triangle, I have to find the long leg. Because the long leg and the height are the same thing. Well, according to your rules at the top, does the long leg equal the hypotenuse times the square root of 3 or the short leg times the square root of 3? Short leg. Have I found the short leg yet? No, so I gotta first find the short leg. Hypotenuse equals short leg times 2. We said our hypotenuse was 25. So 25 equals short leg times 2. Divide both sides by 2, and what would be the length of our shorter leg? 12 and a half. That's this little guy down here. Now I can use that to get to my long leg. Because Larry, what did you say long leg equals?
Short leg times the square root of 3.
Good. So then my long leg would have to equal 12.5 square root 3. You agree, Larry? Okay. So then that would go right here. And remember, the long leg was the same as the height. So now, to find the area, I'm supposed to take base times height. Well, we just figured out the height is 12.5 square root 3. The base is any of the sides. So is it the bottom, the left, the top, or the right? That makes a right angle with the height. Which side makes a right angle with my red line? The bottom. What's the length of the bottom? 25. This whole thing down here is 25. So to find the area, you have to take 25 times 12.5 square root 3. It says to the nearest foot plus 2, which implies what? Round. So you've got to use what then? A calculator. Nearest foot round to what place value? No. Whole number, right? Nearest foot would be round to the whole number, the ones. What do we get? I don't remember. About 541 feet squared. Remember, area is squared. There. Base times height. You have to drop the height in there and you're going to create a special right triangle. Sometimes it could be a 45, 45, otherwise 30, 60. Okay, we're going to try another one of these. So right below that. A rhombus has 10-inch sides, 2 of which meet to form the indicated angle. Find the area of the rhombus. We're not going to do B, because we just did one with a 60-degree angle, so you can kind of cross through that. We're just going to do part A. Our rhombus, we want to find the area of, creates acute 30-degree angles. So do your best at drawing a rhombus. I'll try and make mine bigger so you can see it. Remember, rhombus have congruent sides, and they told us in the directions there for 4 that they're all 10 inches. And we need to find its area. Area of a rhombus, remember, base times height. The base can be any of the sides. The height has to be the perpendicular segment. Our rhombus on A form 30-degree angles. If you want it to be drawn more to scale, then put your 30-degree angle in your acute looking angle. So should I put it in the left one at the top or the right one in the top? The left one, that looks more acute than the other one. You could also put it down here, it wouldn't matter. So then our height has to be perpendicular. Again, you could have drawn one coming down over here if you wanted to. I just drew mine on this side. But this is going to be our height. Okay, So my little triangle that we created, this angle by the rhombus was 30. The height made 90. The height and the rhombus over here down here make a what degree angle? 60. 30, 60, 90. Triangle sum theorem, they all have to add up to 180. So then, oh, dog. You dog. Smart. Alright, there's our little 30, 60, 90 right triangle. The height, is it across from my 30 or my 60 degree angle? 30, which indicates it should be which leg? The short leg. And this little chunk up here is technically your longer leg. That's what I mean, don't go based off of looks. Because I didn't draw it to scale to scale. This must be a shorter rhombus than what I have. Okay. The left side of our rhombus is our triangle's hypotenuse. And we know the length of it, it's 10. Each side of our rhombus was 10 inches. Find the area, I gotta take base times height. So I've gotta find the height, which is the same as the short leg. And they've given me the hypotenuse. So at the top, the hypotenuse rule reads what? Hypotenuse equals short leg times 2. Well, the hypotenuse is 10. So 10 equals short leg times 2. So when I divide by 2, what's the length of my short leg? 5. Which is the same as the height of the rhombus, right? Yes, okay. So we know that the area of a rhombus is found by taking base times height. Well, the height's 5, so I'm going to put 5 there. The base and height have to make a right angle. Well, the height's making a right angle with the top of the rhombus. That's the base in this case. What's the length of the top of the rhombus? What'd you say? 10, yeah. So what's the area of this rhombus? 50. 50 inches squared. So don't go based off of the picture. When one leg looks longer than the other, make sure you look at the angles. Most of the time I'll get them drawn to scale, but not always. And then if you really draw your own, then it kind of really screws it up. Thanks, Larry. Alright, so we'll have a couple like that today. Hopefully you took good notes on that. Our last one, number 5. 2 millimeter sides of a triangle, excuse me, 2 12 millimeter sides of a triangle form a 120 degree angle. Find the length of the third side. 2 of the sides are 12 millimeters. Therefore, our triangle is what kind of triangle? Isosceles. It's got 2 equal sides. And those 2 equal sides meet to form what kind of an angle? Right. Obtuse. It says it's how many degrees? 120, right? Okay. So draw yourself an obtuse isosceles triangle. Mine's giant. You probably don't have to draw it this big. 12 millimeters. 12 millimeters. And it says those 2 sides meet to make 120 degrees. We want to find that third side, in this case the bottom on my picture. I know 2 of the 3 sides. Can I use my Pythagorean theorem? Most squared equals. Why not? Because it's not a right triangle. Cool. Kaden?
Is it only in equilateral triangles that you can just take that and like divide it by 2 to get the smaller angles?
Like the last 2 missing angles?
Yeah.
Well, not necessarily. What do you know about those last 2 missing angles?
That they're equal.
That they're equal. And since it's a triangle, all 3 angles have to add up to what?
180.
So 180 take away 120 is 60, right? Cut 60 in half. 30. Nope, you can do that in isosceles triangles. Those would each have to be 30 degree angles, those base angles. We've been working with all chapters so far.
Right triangle.
What kind of triangles?
Right.
Right triangles. Do I have one here?
You kind of
I gotta make it, right? Okay. You have to, I always say drop a perpendicular down. You gotta drop a a line down. You have to draw in a line to make a right triangle. That's the altitude. From a vertex perpendicular to the other side, we're just drawing in the altitude. Okay, so when I look at the right triangle that we've made, I'm just gonna look over here on the right side. Obviously we have our right angle, the 90-degree angle, and then Caden helped us figure out that this little guy is 30, so this last angle up here would have to be what? 60, right? So what kind of right triangle did we make over there? A 30, 60, 90. And we know that this side is 12. Is that short leg, long leg, or hypotenuse? Hypotenuse. Remember, we're trying to find the whole bottom length down here. So I'd have to find, I don't know, I'll just call this X. Is that my long leg or my short leg? It's my long leg, right? Because it's opposite of the 60. Does one of our rules go hypotenuse to long leg? No, it goes hypotenuse to short leg, which would be the altitude that we've drawn in, so I'm going to call that Y. The hypotenuse rule for your 30, 60. Hypotenuse equals short leg times 2. So then we're saying 12 equals Y times 2. Divide by 2, and what's the length of our altitude there? Y. 6. Now that I know the short leg, I can find my long leg, because your long leg rule at the top says long leg equals short leg times the square root of 3. So then we would say X equals 6 times the square root of 3, right? Can't make that 18 ones inside, ones outside. Okay, so this bottom right side is 6 square root of 3. They wanted us to find the third side of the huge triangle. That would be the whole bottom. What would I do with 6 square root of 3 to find the whole bottom line? Times it by 2. Those two little triangles are congruent. So if this half is 6 square root of 3, then we just need to take that thing times 2 to get the whole length. So then your whole length would be 12 square root of 3. Make right triangles. If there's not one there, draw a perpendicular line down. Most of the time it's either going to be vertical or horizontal to either make your 30, 60s or your 45. Questions? Alright, we got another worksheet today. We'll do a review worksheet tomorrow, and then you have a quiz on Wednesday.
I'll get it
We're
for
gonna
you.
do seats on Wednesday.
Probably Monday next week.